get bulls out, a kid don't play. If there was a problem, yo, I'll solve it. Check out the hook while my DJ revolves it.
Hi everybody, welcome back to my YouTube channel, Past Math with Miss Passarella. I'm your favorite math teacher, Miss Passarella. Today we're going to solve absolute value equations, but before we get started, don't forget to like, share, subscribe, tell me I'm adorable, and give a comment. But also before we get started, let's make sure we remember what absolute value is. An absolute value is the distance from 0 on a number line. Don't forget that distance cannot be negative, so even if you take the absolute value of a number, your answer can never be negative. Distance is always positive. So here's a number line, and if I take a look at the 3 questions I posted, the absolute value of positive 5 is 5 because I'm 5 units away from 0. And the absolute value of negative 5, so there's negative 5 on the number line, it's 5 to the left, but I'm still going to move 5 units positive to get to 0. And then the absolute value of 0 is 0. Please don't get confused that once you take the absolute value of something, you have to drop your bars. And again, a lot of people might think that if you take the absolute value of something that it's the opposite number, and that's just not true. So today we're going to go over a few questions. We're going to go over equations with no constant. We're going to go over an equation with no solution. We're going to go over 2 equations where the constant is outside the bars. We're going to go over 2 equations where the constant is inside the bars. And we're going to go over a word problem, and I have a little surprise for you when we do our word problem. We might have a special guest coming up soon. Stay tuned. Today's learning target is I can solve absolute value equations. I'm going to go through 7 examples, and I'm going to make sure that we follow the steps every single time, even if it doesn't seem necessary, because you're going to see why being consistent with your steps is going to make it easier as the questions get more difficult. So the steps that we're going to follow are make sure there's nothing outside the bars, no constants, no coefficients. We're going to get rid of all those ahead of time. Then we're going to drop your bars. And once you drop your bars, you're going to split it into 2 equations. We're going to have a negative total and a positive total. And after that, you're going to solve both equations separately, and then we're going to go through how to check some of them as well. All right, so example 1. There's no constant here. There's nothing outside the bars. This one is probably the easiest one we're going to be dealing with today. So what number could you plug in here to make the absolute value of x equal 5? There's 2 answers that could possibly work. So I'm going to go through my steps. There's nothing outside the bars. So I'm going to drop my bars and split it up to a negative total and a positive total. So I know that whatever number I plug in here should work. So the first one is drop the bars and it's negative 5. And then again, drop your bars and it's positive 5. So if I were to check this, the absolute value of negative 5 is equal to 5. It does check out. 5 does equal 5 when you're done. And the same thing would happen if you plugged in positive 5. A lot of people might think that if you plug in and then you have the absolute value of a positive number, that your answer is opposite, and that's just not true. So for example, if you do this, just make sure that you don't put negative 5 here. A lot of people do that on accident. So this one also checks. Okay, next equation. This one is a little bit trickier. It looks very similar to the first one. However, let's go ahead and start this one by doing a check first. Let's say you think, oh, well, it's always the opposite or something like that. So I'm going to plug in, let's say you even think it's negative 5. If I plugged in a negative 5 here, the absolute value of negative 5 is positive 5. So this equation here is not true because positive 5 does not equal negative 5. Even if I did a positive 5, let's say I plugged in positive 5, the absolute value does not mean do the opposite. It's positive always. So this is also not true. Therefore, if there's nothing outside the bars and the total of your equation is negative, there's no solution. So a 0 with a slash, no solution will actually work here. It doesn't exist. So be careful. When there's nothing outside the bars and the total's negative, there's no solution whatsoever. All right, example number 3. Right now there's a constant outside the bars. So step 1, get rid of everything outside the bars. I'm going to go ahead and do that. There's a plus 2 outside the bar, so let's get rid of it by subtracting 2 to both sides. So now I'm left with the absolute value of x is equal to 7. And now this looks just like example number 1. So I'm going to split it. This might not seem necessary, but I'm telling you, once we get to example 5 and 6, you're going to see why we need it. So I'm going to drop my bars and put a positive solution or a negative solution. So negative 7. And then I'm going to drop my bars and put a positive solution. Yes, you can represent your answer as x equals plus or minus 7. But it's not always going to come up like this. The answers are not always going to be opposite. So that's why I like to follow the steps and be consistent. I'm going to go ahead and check one of these equations just to make sure we're on the right track. So let's say I plugged into the equation negative 7, or the absolute value of negative 7 plus 2 is equal to 9. So the absolute value of negative 7 is 7. And 7 plus 2 is 9. So 9 equals 9. That checked out. We are all set. And you're going to get the same answer if you plugged in positive 7. All right. This one's a little bit trickier. People might think that this one has no solution because the total is negative. However, there is a constant outside the bars that I do need to adjust before I can drop the bars. So I'm going to add 5 to both sides. Just to follow step 1, everything outside the bars needs to go away. So now I have the absolute value of x is equal to negative 2 plus 5 is 3. And now again, this looks just like equation 1 and also like equation 3. So I'm going to split it. I'm going to drop the bars and I'm going to put a negative solution. So I've got negative 3. And then I'm going to drop the bars and put a positive solution, which is 3. I'm going to, again, only check one of these. Actually, I'm not going to check this one because I think it's self-explanatory. I'm going to go ahead with example 5. And now this one I'm going to check, and I'm going to show you a common error here. So right now I have a constant inside the bars, and I can't have anything outside the bars before I start. So right now there's nothing here. So I'm going to go ahead and split it. I'm following my rules, and I'm going to put a negative total and a positive total, but I'm going to drop my bars first. So negative total, drop your bars, it's x plus 2 equals negative 9. And then the positive equation will be drop your bars, x plus 2 equals 9. So you could see that it's the same equation, but when I dropped my bars, I took the total and I made a positive and negative. I technically did the same thing here when there was nothing outside the bars. So now let's go ahead and solve. I'm going to subtract 2 from both sides, and I'm left with x equals negative 11. That's one solution. And then the next solution, I'm going to subtract 2 again from both sides, and I get x equals 7. So the reason why I didn't like to put plus or minus like we did here is because these aren't plus or minus answers. They're completely different answers. We've got negative 11 and we've got positive 7. So I want to go ahead and check these ones just so you can see that both of these equations do work, or both solutions do work. So I'm going to write negative 11 plus 2 all in bars. And this is the negative answer. So this is negative 11 plus 2 is negative 9. And then the absolute value of negative 9 is 9. So this one did check out. And now I'm going to go over the positive check. And the positive check is I've got 7 plus 2 all inside absolute value bars. And the absolute value of positive 9 is also 9. So that one did check out. All right, let's go over one more question here. Example 6. Again, I'm going to follow my rules, and I'm going to go over a common error here as well. So I'm going to go ahead. I see nothing is outside my bars, so I go ahead and split it, and I do a negative total, drop my bars. So x minus 3 is 4, or negative 4, excuse me, a negative total. A common error here would be people would forget to drop the bars and they would put it like this. And if they did put it like this and they forgot to drop their bars, you would get no solution because you can't have nothing outside the bars with a negative total when you're solving absolute value equations. So be careful here. You can't have that. You have to drop your bars every single time. So I'm going to get rid of that and let's just solve it appropriately. I'm going to add 3 to both sides. And my answer is negative 1. And now I'm going to do this positive total. And I'm going to drop my bars and put the positive total. And I'm going to add 3 to both sides. And I get x is equal to 7. So again, when the constant was inside the bars, the answers were not opposites. They're a little bit different. So I can't always just do a plus or minus answer. Let's go ahead and check to make sure that both of them work out. So I've got negative 1 minus 3, all in bars. I got negative 4 equals 4. So this one does check out, but so does the 7. So I'm going to do 7 minus 3 equals 4, and the absolute value of 4 does equal 4, so this one also checked out. All right, everybody, for this last question, example 7, we're going to do a word problem, and we're still doing an equation where the constant is inside of the bars. So I'm going to go over the word problem, and we're going to talk about how the graph that I have down here matches up with the word problem and also matches up with the equation. So starting from 100 feet away, your friend skates towards you and then passes you. He skates at a constant speed of 20 feet per second. His distance d from you in feet after t seconds is given by the equation d equals absolute value 100 minus 20t. We're going to go over what that means in a second. After how many seconds is he 40 feet away from you? Oh, is that a knock at the door? I wonder who that could be.
Hey, Miss Passarella.
Oh, my goodness.
I brought you your coffee.
Everybody, it's my bestest bestie in Bestie Town, Mr. Neiro, the English teacher.
Oh, you're making a video again?
I am making a video.
That was such a fun skating trip, Miss
It was a fun
Passarella.
skating trip. We played the sports ball.
Yeah,
we were skating.
all that stuff.
It was so much
fun. I just came by to make sure that you were using your context clues, because I'm pretty sure I heard that you were doing a word problem.
Yeah, we are using our context clues, Mr. Neiro. That was some great advice.
Thank you. Just wanted to make sure. Listen, I have to run, but enjoy your coffee.
Oh,
Make
you're
sure
so
they got
adorable,
it right.
Mr. Neiro.
No, you.
No, you.
No, you.
You. All right, have a good day.
All right, bye, kids.
Thanks for stopping by. Well, that was so nice of my bestie, Mr. Neiro, to stop by and make sure we're using our context clues while solving this word problem, because that's exactly what we're going to do to write this equation. So the equation I'm actually going to write is going to be 40 equals the absolute value of 100 minus 20t. And the reason I replaced the 40 with d is because d stands for distance, and I wanted to know when my friend was 40 feet away from me. So if I'm actually going to use me in the word problem and then Mr. Neiro as my friend, so that we can kind of break this down a little bit better. You can see our Bitmojis down at the bottom. Look at how cute we are skating together. He's going to actually skate towards me. So the reason why the constant here is 100 is because we started 100 feet apart. And you can see that down on the diagram below, that we're 100 feet apart from one another. And then also the reason that the unit rate is 20t or minus 20t is because in the word problem, he's skating 20 feet per second. The reason it's negative is because he's going towards me, and since he's going towards me, the distance between us is getting smaller and smaller. So let's take a look at how that looks on the graph, and then we're going to solve it algebraically. So here we go. We've got me and Mr. Neiro. I'm representing 0 on a number line, and he's representing 100 feet. You can see that right here. That feet is on this number line, and so is seconds. So for every time I'm going to jump 1 notch on the number line, he's really skating 1 second, and that's 20 feet closer to me. So if he goes 1 to the left, at 1 second, he is 80 feet away from me. At 2 seconds, he's 60 feet away from me. At 3 seconds, he's 40 feet away from me, and that's actually our very first answer because the question said, after how many seconds is he 40 feet away from me? So the first answer we could see is 3. And then we're going to match that up algebraically in a second. However, there's not just one answer, there's 2 answers. So the first one is 40 feet when he's approaching me, and then the next one is going to be 40 feet after he passes me already, and we can kind of see that on the number line already. So at 4 seconds, he's 20 feet. 5 seconds, we meet. 6 seconds, he's 20 feet past me. And 7 seconds, he's 40 feet past me, and that's our second answer right here. So the 2 answers we have are at 3 seconds and at 7 seconds. Those are the 2 places that he's 40 feet away from me while skating towards me and then passes me. So I'm going to do the same exact thing I've been doing for all the rest of the absolute value equations. I'm going to have a positive total and a negative total. And I'm going to first, since I see that there's nothing outside my bars that I have to worry about, I'm going to drop my bars. Remember, don't forget to drop the bars. You have to drop the bars. If you don't, sometimes the negative total would have no solution, so be careful. So I've got negative 40, drop the bars, 100 minus 20t. And I'm going to go ahead and solve this the same way I would solve a 2-step equation. I'm going to subtract the constant. I get negative 140. Also, be careful of your integers. There's a lot of negatives and positives here. Minus 20t. I'm going to divide negative 20 to both sides. Do it to one. Do it to the other. And t is equal to, be careful, a negative divided by a negative is a positive. And 140 divided 20 is 7. So that was our first answer. And look, that's exactly what we got when he passed me, the negative solution. Or the negative total once we drop those bars. That's right here. All right, now let's take a look at the positive one. So again, drop the bars, put a positive total, 100 minus 20t, and I'm just going to go ahead and solve again. Oh, don't want to forget the ladder. So minus 100, do it to one side, do it to the other. I've got negative 60 this time. Be careful with those integers. Minus 20t. Divide negative 20 to both sides. And t is equal to 3. So I've got 3 seconds here. I got 7 seconds here. And take a look. That was actually the first answer we got on our number line when we looked at it as a diagram or a picture before we solved it algebraically. I hope this helps. I hope it makes sense. If you have a question, make sure you comment below. Don't forget to like, share, subscribe. Tell me I'm adorable. Tell Mr. Neiro he's adorable. And I'll see you again real soon. Bye, guys.
Was a problem? Yo, I'll solve it. Check out the hook while my DJ revolves it.